Hello again, everybody. We're going to be talking about scale factor today. So this is just building upon our scale drawing unit. So the definition that we need to know for scale factor is the scale written as a ratio in simplest terms. The important thing to remember with scale factor is that these ratios must have the same units. So we are going to be doing a lot with converting units with scale factor. Okay, so let's take a look at example 1. It says find the scale factor of a model sailboat if the scale is 1 inch equals 6 feet. So the first thing that I want to do is I want to take our scale and I want to write it as a ratio. So I'm going to put 1 inch on top and 6 feet on the bottom. Okay, so in order for it to be a scale factor, remember we have to convert our units so that the units on top match the units on the bottom. So I'm going to convert my feet to inches. So if I do that, I'm going to keep my inches on top, and essentially I'm going to take my 6 feet and multiply by 12 inches. So 12 is really my conversion factor because there are 12 inches in a foot. So when I do that multiplication, I'll still have 1 on top, and then I will end up with 72 inches on the bottom. So my scale factor would just be 1 over 72. Okay. All right, so let's take a look at example 2. What is the scale factor of a model car if the scale is 1 inch equals 2 feet? It's going to be very similar to number 1. So if I set up my scale as 1 inch over 2 feet, I know that I have to convert my feet to inches. So I am going to take my 2 feet and multiply by 12 inches. When I do that multiplication, I will get 24 inches in my denominator, so I have 1 inch over 24 inches. So once again, scale factor 1 over 24. Okay. So now we are going to kind of extend what we know about scale factor in scale drawings and apply it to solving problems. So it says scale factor can also be used to solve problems. You need to interpret the situation to determine how to use scale factor. Since a scale factor uses the same units, you may want to think of your unit rate in terms of model over actual. Okay, so let's look at example 3. It says a model rocket was built using a scale factor of 1 to 15. If the height of the actual rocket is 9.9 meters, what is the height of the model in millimeters? So just like we did with our scale drawings, the first question we need to ask ourselves is, what are we looking for? In this case, we're looking for the model. It says, what is the height of the model in millimeters?
Will you come to the main office?
So when we set this up, we're going to set up our scale factor so that 1 is on top and 15 is on the bottom. Since we are looking at model over actual, we're looking for the model. Okay. So from here, I am going to convert. We need to think about our unit. So I'm going to want my final answer in millimeters. So I'm given the actual height of the rocket, which is 9.9 meters. So we need to convert this to millimeters. Well, for every meter, there are 1,000 meters in a meter, or a millimeter, 1,000 millimeters in 1 meter. So if we have 9.9 meters, we know that we are going to actually have 9,900 millimeters. So that's our conversion right there. So I am going to take 9,900 and multiply it by my scale factor. If I multiply straight across, I have 9,900 over 15. And then if I divide that out, the numerator divided by the denominator, I will get 660 millimeters as my answer. Okay. Number 4. A backyard playhouse was designed after a real house using a scale factor of 3 to 5. If the ceilings in the playhouse are 6 feet tall, how high are the ceilings in the actual house? Okay, so what are we looking for in this case? In this case, we're looking for the actual. So when I set this up, I'm actually going to take my scale factor and write it as 5 over 3. Now, since the playhouse is in feet and the actual house is going to be measured in feet, I don't have to worry about converting any units because they're already in the same unit. So I am going to take my scale factor and multiply by 6 because I know that's the height of the playhouse. So if I multiply straight across, I would get 30 in the numerator and 3 in the denominator. That can be reduced. 30 divided by 3 gives me 10. So my answer would be 10 feet. Okay, example 5. A dinosaur figurine was built using the scale factor of 1 to 42. If the actual dinosaur is 12 1/4 feet tall, what is the height of the figurine in inches? Okay, so I'm looking for the height of the figurine, which means that I'm looking for my model. So when I set up my scale factor, I'm going to keep 1 in the numerator and 42 in the denominator. Now, the tricky part here is that I need to convert this from feet to inches. So I know that in 12 feet, I could take 12 feet and multiply by 12 inches. There would be 144 inches in 12 feet. But now I have 1/4 of a foot. So 1/4 of a foot, we could take 1/4 and multiply by 12. And when we do that, that's essentially like 12 divided by 4, which would give me 3 inches. So the total number of inches in 12 1/4 feet would be 147 inches. So we come back over here, and we're going to take 1 over 42, and we're going to multiply that by our 147 inches. And when I do that multiplication, I would get 147 in the numerator, 42 in the denominator. And if I divide that out, I would get a total of 3.5 inches. So that would be the height of the figurine in inches. As always, if you have any questions, please write them in your Google form and bring them to class tomorrow. See you then. Bye.